Welcome to This Explainer. Today, we're diving into what I honestly think of as a forensic detective story for cloud and IT ops professionals. We're going to track down and fix those invisible performance bottlenecks that are just lurking in your Oracle Kubernetes engine or OKE clusters. So let me ask you, have you ever chased a ghost CPU spike? You know the exact scenario I'm talking about. Your pagers go off, hundreds of alerts completely flood your dashboard, but by the time you actually log in to check your standard monitoring tools, the spike has completely vanished. It's incredibly frustrating, and it leaves you totally blind to what just impacted your application. Well, this really gets to the root of that problem. Standard Kubernetes metrics usually pull data in these aggregated 15 to 60-second intervals. But the reality of your application might be a vicious 5-second resource spike that can literally crash your container. Think about it. If your security camera only snaps a photo every 60 seconds, you are going to completely miss the 5-second crime spree happening right in between those flashes.
So here's our roadmap to bridge that dangerous visibility gap today. We'll start with the Kubernetes visibility gap, meet nmon for OK, go over deploying by a containerized daemon sets, talk about the absolutely critical -u flag, catch some spikes in action, and wrap up with best practices for production.
All right, let's jump right into part one, the Kubernetes visibility gap. Now, we all know Kubernetes is fantastic for orchestrating containerized workloads, but those very layers of abstraction inherently complicate performance troubleshooting for IT ops. Like we just talked about, standard monitoring solutions act like a super slow security camera. Because they average out metrics over longer intervals, they completely mask the short-duration resource spikes that drastically impact application performance. You might see a tiny little bump in a 1-minute average, but you won't see the massive 100% CPU lockup that lasted for just 3 seconds and caused a whole cascade of application timeouts.
Moving on to part 2, meet nmon for OKE.
To solve these mysteries, we need the right forensic toolkit. Enter nmon, which stands for Nigel's Monitor. Originally developed by IBM, it's an incredibly lightweight yet powerful performance tool. And what's really interesting here is how it captures simultaneous insights. We're talking CPU utilization by core, memory usage, disk I/O, network throughput, and top processes all at once. It essentially acts as the ultimate magnifying glass, allowing us to correlate different metrics and spot hidden bottlenecks at the exact same time.
Which brings us to part 3, deploying via containerized daemon sets.
To catch anomalies across an entire cluster, doing things node by node manually just isn't going to cut it. We have to deploy this toolkit efficiently. Step 1. You create a simple Docker file for nmon. Step 2. Build and push that image to your Oracle Cloud Infrastructure Registry. And Step 3. Apply the daemon set YAML. This simple 3-step process guarantees that nmon runs continuously and consistently on every single node in your cluster, with 0 manual setup required.
Next up, part 4, the critical dash flag. And trust me, this one is a game changer.
We really need to focus on this one vital configuration detail. Because without the -t flag, you'll capture system metrics, sure, but you won't be able to identify which specific processes are actually consuming the CPU. This crucial point makes the difference between catching the culprit and just hoarding gigabytes of useless data. Without it, you might see that your CPU spiked, but you won't know if it was a rogue Java thread, a Prometheus scraper, or some Ruby process. Without process-level visibility, troubleshooting is practically impossible.
The beauty of this is that we can dynamically switch our configurations to handle different situations. For a production configuration, you run it at 30-second intervals. That gives you continuous monitoring with incredibly low overhead. But when the alerts start firing, boom, we dynamically switch to our troubleshooting configuration. We drop that interval down to 1 second, and we add the -t for top processes, -p for process arguments, and -T for top threads. We are essentially shifting from a time-lapse security camera to a high-speed forensic camera exactly when the trouble starts.
Let's see what this looks like in part 5, catching spikes in action.
Let's look at a real-world use case where an OKE cluster was getting hammered by sub-minute CPU spikes that standard tools entirely missed. 45.2%. By dynamically switching nmon to 1-second intervals and making absolutely sure that crucial -t flag was active, the operations team caught a hidden Java application process, PID 12345, consuming 45.2% of the CPU. And this was during a spike that lasted less than a minute. Standard monitoring tools didn't even blink, but nmon caught it red-handed.
Once you actually have this granular data, you can use a tool called nmon to do some visual forensics. It generates these great interactive HTML charts. Think of it like matching fingerprints. If you see high CPU wait percentage combined with high disk busy percentage, well, you've just pinpointed an I/O bottleneck. If you see a high runnable process count with a high user percentage, that's CPU contention. And if you see a specific process spike right alongside memory pressure, you've found a process-specific resource issue. You're correlating multiple dimensions to pinpoint the exact root cause.
Finally, let's wrap things up with Part 6, Best Practices for Production.
So how do we safely and effectively operationalize this technique in live cloud environments? First off, always match your polling interval to the problem duration. If the spike is seconds long, you need to use 1-second intervals. Second, and please don't skip this one, plan your storage. 1-second data surges generate incredibly high data volumes compared to standard 30-second polling. Because of this, you absolutely must implement strict file rotation and archiving policies so you don't fill up your node's disk space. And finally, I'll say it one more time, always use that -T flag during active incidents.
Which brings us to a final, pretty crucial question. Are your current monitoring intervals hiding your biggest performance threats? Honestly, if you're relying solely on 60-second aggregates, the answer is very likely yes. It is definitely time to rethink your observability strategy and deploy some high-resolution forensics to catch those ghosts in your cluster. Thanks so much for joining me on this explainer, and hey, happy troubleshooting.